Okay, now we're back to the B&K Model 650. So one of the first things that I did, and I've skipped ahead a little bit here, but in the maintenance manual for the 650, there are a series of voltages that you can test, and they're on a set of pins inside the main unit. Now the main unit is over here, and we'll have to turn it upside down, and I'll show you where those are in a minute. But basically what I did is I copied the pin numbers onto this sheet so it'd be easy to match between these and these voltage readings, and also the schematic, which is right here. Those pins are shown right along the outside here, and each of them has a value. Some of them have no connection. For example, those top two should have 117 volts or whatever the AC line is across them, and so on down. The next thing I did was I tested all of those voltages, and they all seem to be within spec. The way I tested them is I hooked up a variac, and the variac is set to put out 115 volts, and 115 volts is what they specify as the correct reading with a 115 volt AC input. And the test switch in the test 1 position, that's this switch, test 1, and of course this is right now turned off. So I used one of these kilowatt meters to give me a more precise reading of the voltage. Now the variac has a voltmeter, but I found it's a little hard to read very precisely. This is a very precise reading, and I've checked it against my other variac that has a better meter, and this seems to be very accurate. So at any rate, it's set to 115 volts. And then after having done that, the next thing was to try to determine whether the meter was good. Remember, the whole purpose of this exercise is to decide whether this unit is worth the time and trouble of recapping and doing all the other things needed to bring it up to original specs. So I have put in a tube. It's a 6U8, and that is listed right there on the panel. You see 6U8 7656. What those red numbers are for are the settings of this sensitivity control. Now, it's a 6-volt tube. Sensitivity, I'm going to start at 0. The reason is that if you look at the schematic, you'll see that the meter, the sensitivity control, which is that one right there, is shunted across the meter. So if you set it at 0, basically the meter is shorted, or essentially shorted. So it's less likely to damage the meter, and I can raise that a little bit at a time up to the settings as shown on the front panel, and that'll tell me whether the meter is any good. So we'll turn it on, and you notice that the pilot light comes on. I'm going to put it in the shorts and grid emission position, and I'll show you a tube here in a minute that does have grid emission, and it will detect it. We'll give it a little bit of time to warm up, and then we'll set it in the test 1 position. Now we'll begin to raise the sensitivity control as we watch the meter. As you see, it's starting to come up, and we should raise this all the way up to 76, which is about right there. And as you see, the meter is coming up into the questionable range, which means the tube is on the borderline, but remember, this tester isn't calibrated yet, so it still could be a good tube. And in fact, I know that on another tester like that Hickok 600A over there. This tube tests a little bit better. It's still near the bottom of the good range, but it does test as good. So the next thing to do is to do test 2, but for that you're supposed to reduce the sensitivity to 56, then go to test 2. And you see once again it is in the questionable area. In fact, just right at the line between replace and questionable. So the main thing is, it tells us the meter is working, most of the circuitry is working. I've already ohmed out all of the transformer contacts and the major controls. That is the sensitivity control and a bunch of the setups inside. And they all appear to be within tolerance. So I think this one is worth doing, and we'll get on now with trying to recap and replace the selenium rectifiers and a few other things. Now, one thing that I do know is that the 83 tube in here is weak. In fact, it's a mercury vapor rectifier, and I'll show you a little later. It's starting to show the usual signs of failure in a mercury vapor rectifier, which is that the readings look okay for a while, and then they begin to fall off as the tube heats up. It should be the other way around. With mercury vapor, the tube should get better as it warms up. So we'll look at that when we get there. For right now, we're going to take a break while we go do some recapping, and then we'll be back. Okay, I've just about finished recapping this Dynaquick, and I'm doing some tests here, but I stopped right now to show you something that I discovered while I was doing the recapping. And that is that there's a shorts feature in the B and K. Right there are the shorts, but the schematic did not show that capacitor, C6, the 0.005 600 volt capacitor. That's the shorts light, the neon light. And I'll show you how it works in just a second. The funny thing is, though, that C6 is shown in the parts list, 0.005 600 volt tubular capacitor. So be aware that apparently there was a production change and that capacitor was removed. I assume that it was replaced with the direct short. But it works fine with the capacitor in there, and I'll show you how I know that in just a second. Okay, what I'm testing right here is a 6U8, and I have it up on that extender so I can actually use the shorts function. The way the shorts function works is when you have a short in a tube, this light right here comes on. It's a neon bulb. So I'm going to set this up on a tripod now where you can see as I apply a 1 megohm short, which is what this tester is supposed to detect, across that 6U8. And I'll be back in just a second. The way we're going to do this is we're going to use this 1 megohm resistor. I'm going to put it between the grid and cathode of that 6U8. And you notice that the shorts light comes on. This tester works fine with that capacitor in the short circuit. That's the one that I showed you earlier that's right there, that 0.005. Now, I haven't yet replaced that capacitor, but when I ran across it, I realized that it wasn't actually shown on the schematic, even though it was in the parts list. So if you're working on some of these old testers, don't assume that the schematic is correct. Sometimes they're not, as in this case. But at least the parts list had it, so I know it's supposed to be in there, and it turns out it works fine with it in there. But I'm going to replace it anyway because it's an old capacitor. It's a paper wax capacitor, and those tend to go out after about 20 or 30 years. So that's one of my next tasks, and that'll be the last capacitor I need to do.